Hello, in this video we are going to look at the nomenclature of acids. Okay, there's two major types of acid that will give you different ways to name acids, and I think the first hurdle is to see that there are two different ways you can name acids because there's broadly two families of common acids. So let's look at the first one. Let's look at binary acids. So let's look at binary acids. Okay, if you have a binary acid, and as you can see, binary means two. So it's really, we're looking at essentially two elements, one of which has to be hydrogen, right? So we're looking at two elements stuck together. So two elements, H and other. Okay, so that's what we're talking about here with binary acids. So we've got an H, and then we've got a variety of other elements that would make monatomic ions. Specifically an anion, because H is going to form our cation. Then the H is going to give us hydro, and then the monatomic ion is going to give us a root, and then a suffix -ic, and then the word acid. So hydro, and then some root, and then -ic, and then the word acid. Okay, so let's see an example of that. So let's look at HI. So that's our binary acid. Let's not have it quite so towards one side, then I'll run out of space. Let's have it right in the middle. Right, so let's say that's our binary acid. So we've got H plus, we've got I minus, that's our monatomic anion. This is going to give us hydro. Scroll that down a bit. All right, hydro, and then the prefix here, because it's from the element iodine, the root would be iode, and then we've got the suffix -ic, and then the word acid. So all in all, we have hydroiodic acid. And you notice this is all one word. That's the way to present it, or that's a way to present it. My recommendation, like in all my nomenclature videos, is to go onto a search engine, look for nomenclature of acids worksheet. You'll find a million of them posted by well-intentioned people, and you can just start practicing some of them. Identify, okay, that's a binary acid, that's a binary acid, look, it follows the rules. That's really how you get down in the trenches and learn nomenclature. Okay, the common examples that I would encourage you to be on the lookout for are HI, HCl, HBr, HF. These are the ones that I'd be on the lookout for. So you've got, so we've already done HI, right? So the other ones we've got hydrochloric acid, we have hydrobromic acid, we've got hydrofluoric acid, and I'll just do the last one because even though we've done it, in case you're wondering what the fourth one is, hydroiodic acid. Okay, so they're the big ones to keep a lookout for, and that's the procedure that you would follow. Let's shift to look at another common type of acid that has slightly different naming convention. These are called the oxyacids. So oxy because it's full of oxygen. If you have an oxy acid, then you're going to have an H because it's an acid, but you're going to have an oxy anion. An oxy anion, which typically will have one of two suffixes. It will typically have either the suffix ate or the suffix ite, which the difference between ate and ite has one more oxygen than ate. And we'll see some examples in a second. If you have an oxy anion that has an 8, then you would do the following. You would have a root, and you would have ic, and you would have acid. If you had the oxyanion that had the suffix ite, you would do this. You would make your arrow connect properly. And then you would do this. You would have a root, and you would have suffix us, and then you would have the word acid. So the big difference here is ic versus us. Okay, so let's see an example. Let's see an example. Before we do, if anyone wants to pause the video, I'll at least have the whole thing. So oxyacid, H, oxyanion, typically ate or ite, rootic acid, rootus acid. Okay, so let's have a look at an example. Okay, let's look at HiO3. So we looked at HI for the binary acid. Let's look at HiO3 for the oxy acid. Okay, so there's our oxy acid. It's full of oxygen. So we've got our cation H, which is going to be H+. Okay. So maybe, don't think it matters if I wrote the plus there, but just to be consistent. Okay, so we have our H+ here. And then we have our anion here, which is IO3-. This is an 8, it's actually iodate. So it's the 8 suffix, or the 8 root So we would write well, sorry, get my acid nomenclature mixed up. We don't mention the hydrogen in this nomenclature. Notice that we completely ignore the hydrogen. So we ignore the hydrogen. Okay, so we ignore that. We're going to focus on the oxyanion. So we have iode is our root, and then we have ic because the oxyanion was an 8, and then we have the word acid, so we are left with iodic acid. So compare iodic acid with hydroiodic acid. So you have to be careful. Hydroiodic acid is not just iodic acid with hydrogen. It's completely different. So you really have to keep your wits about you with acid nomenclature. Let's look at one more example just because we have a bit of space. Let's look, we'll do a couple more examples. Let's look at HClO3. So we have H plus that we're going to ignore, and then the all-important ClO3 minus. This is known as the polyatomic ion chlorate. So it's an 8. So we know what to do. We have chlor, ic because it came from the 8, and then the word acid. So the whole thing just becomes chloric acid. What if we had, so that was HClO3. What if we had, maybe I can fit it alongside. Try and fit it over here. I don't know, let's see how much space I've got left. We have enough, I'll do it over here. What if we had HClO2? So this is one less oxygen than we had before. So I've got a feeling this is going to be an ite, but let's see. Let's not spoil it. We have H plus ClO2, which I can confirm is chlorite. We ignore the H. We've got an ite. So we've got our root chlor. Our ite becomes the suffix us, and then we add the word acid. So we have chlorous acid. Okay. Again, my sage advice would be to just look at some examples. I've shown you the basic way to approach the problem. It's your job to practice as many examples you need to get all the nuances that you might need. But that's the meat and potatoes of how you would do it, and that is the nomenclature of binary acids and oxyacids, and that will wrap up this video.